Okay, good morning, good morning. Today we are going to review 3-5 and 3-6. We're not going to actually finish the rest of 3-6 because we don't actually need to. So what we're going to do is review what we need to know from 3-5 and 3-6 for the next test. Okay, so I recommend putting these in your notes. All right, so first question, if you need to pause the video, I'll obviously do that to write the things down. I do have a number 5 and 6 that I will move up in a moment as well. But I'm going to get going right away here. So the first question, suppose U equals 0, 2, 4, 6, 8, 10 is the universal set and H is 2, 4, and 10. What is the complement of H? So first of all, you have to remember what that means. This little sign right here means the complement, and complement means that what is in this set that is not in this set. So, H contains 2, 4, and 10, so the complement of H would be what is not in there? 0. 2 is in there, 4 is in there, 6 is not in there, 8 is not in there, 10 is in there. This right here is the complement of H. It's everything that is in this set that is not in that set. Cool. All right, let's move on. List the subsets of 2, 8, and 12. So remember, subsets is every combination, order not included, it doesn't matter, of these three that we can come up with. So every combination, I like to start with all of them. So the first subset I'm going to list is the exact thing that it says, 2, 8, and 12. All right. So the next one I'm going to move to is, okay, well, what happens if there's only 2 of these? What combinations could we get? So we could have only 2 and 8. We could have only 2 and 12. Is there another combination of 2 that we haven't done yet? Yeah, we can have just 8 and 12. And that's every combination of 2. And now let's talk about combinations of 1, which isn't really a combination because there's only 1. So we could have just 2. We could have just 8. Oh, my brackets today are bad. We could have just 12. So that's every combination of 1 in this case. Is that all the possible combinations? No, it is not. There is one combination, the most commonly missed combination for any of the subset questions is students miss the last one, and that is the empty or null set. That has to be included in every list of subsets. Okay, good. So that is the question. Don't forget the empty set when you take a test on this. All right, next. Write an inequality for, and then there's the graph. So since there are 2 dots on here right away and 2 arrows, you know it is a compound inequality. And in this case, the arrows are pointing outward, which means what word is going to go with it. Outward means the word or has to go with this inequality. So let's focus on the one on the left. So we would say this. Any letter will do, but we're going to do X, right? The arrow is pointing to the left, right? So that means our inequality is going to point like that too, like it's an arrow to the left, and we need a -2 in there. Now, is this going to have a line underneath it? No, because it's an open circle, right? And then we're going to use the word or because it's pointing opposite directions. And then we're going to focus on this one, X. In this case, our arrow is pointing to the right. And so our inequality will look like an arrow pointing to the right. And it is going to have a line underneath it this time because it is a closed circle. And then the number that it's around is +1. This is the answer for the inequality for that. All right. If it had been pointing inward, we would use the word and, or we would put it back together where our variable's in the middle. Okay, let's move on to solving and graphing now. All right, so I'm throwing it back just a little bit because this stuff is going to be on the next test as well. And it's come to my attention that these are some of the missed ones. Okay, so if you are asked to solve and graph this, 2 ways you can do it. You can either look at this as x divided by 5 is greater than -2. Or you can take that out of there. You can put a 1 in front and make this 1/5 x is greater than -2. Okay. Whichever way you do it, you should come up with the same answer. If you do it like this, you're undoing a divide and you times by 5 here to cancel it, and you times by 5 over here. So you would get x is greater than -10. If you do it this way, you multiply by the reciprocal, 5 over 1, to cancel that out. Multiply this by the reciprocal, 5 over 1, and you still end up with x is greater than -10. All right? Either way you solve it, you should get the same answer. To graph this now, so we're going to draw our number line. There is only one number, so we have to make sure that we get -10 on there, right? Put a few numbers around it. -9, -8, -11. We're going to have an open circle around that -10. The arrow is pointing to the right, so our arrow points to the right. This is a singular inequality, so we only make a single graph. This is the answer. Here's the inequality, and there's the graph. Okay, again, before we even start, since there's only one inequality sign here, this is going to end up being a singular inequality when we graph it again. All right, let's go ahead. Starting here, the parentheses, we must get rid of those first. Let's go. 5 times x is 5x. 5 times 2 is +10. Greater than or equal to -3x plus 10 plus 8x. Okay, too many x's going on here. So this side, we can combine like terms, right? So let's leave our 5x plus 10 is greater than or equal to. Now we're going to combine -3x and +8x and get +5x. Bring down plus 10. And now you see something unique. You have the same thing on both sides. Let's keep solving it just to show what happens in the end, okay? So let's cancel one of these x's. Let's cancel this one, -5x, -5x. All right. And so you end up with 0x plus 10 is greater than or equal to 10. All right, now let's cancel the 10. -10, -10. And you end up with 0x, I'm putting it up here, is greater than or equal to now 0 is what you end up with, right? So let's think about this. 0 times anything is what? 0, right? So we really end up with 0 is greater than or equal to 0, don't we? Okay. So is 0 greater than 0? No. But is 0 equal to 0? Always. All right. And so because there's the or equal to sign on there, this one is infinite solutions. If there hadn't been the or equal sign on there, right? Like if it had just said 0 is greater than 0, then it would be no solution because 0 is never greater than 0. How do you graph infinite solutions? Well, you make a graph and you can actually put any numbers on it. I'm going to put 0 and -1 and -2 and 1 and 2. And the graph looks like this, where it is a solid line with no dots really on it, just going both ways. That's the graph for infinite solutions. It includes everything. Okay, last but not least for our little review here. Okay, solve and graph this one. In this case, notice there are 2 inequalities in there. This means this is going to have a double-barreled graph. Either it's going to have 2 dots that point inward or it's going to have 2 that point outward, okay? So if it's written like this, it's hard to tell, so you have to separate them, solve them, graph them, okay? So by separate them, I mean let's focus on the first inequality first. So we have 4 is less than x plus 7. So let's solve that. 4 is less than x plus 7. And actually, I'm going to write the other one too. So the other one is x plus 7 is less than or equal to 12. All right, so we have to solve each of these. Okay, this one's backward, right? But we can still see what to do. The first thing we're going to do is we're going to undo that plus 7 by subtracting it. -7 here, -7 here. 4 minus 7 is -3. Is less than x. Okay, so half of it is done. Let's solve this one. again, we're going to subtract 7. All right. So we've got x is less than, forgot to put a subtraction, less than or equal to 5. Okay, now is this an and or an or? This is where I want you to graph it first, okay? So if I graph this guy, I know I need a -3 and a 5 in there. Okay, great. So let's do that. So -3, -2, -1, 0, 1, 2, 3, 4. Ooh, it's going to be close. 5. That's fine. That's at the end. All right. So this one is written backwards for the trick, right? So to be able to graph it and make sure we're doing it right, let's flip it back around. Let's put the x on the left, the -3 on the right. Oh, the alligator right here is eating the x. So make sure the alligator's eating the x, okay? So this we only use so we can graph it. All right, so we're going to put an open circle around -3. This arrow, now that we have it the right direction, is pointing to the right. So I know it's going to go right, but is it going to connect is the question, right? So over here now, this is the right direction. We're going to put a closed circle around 5. Okay, and this is pointing to the right. So we're going to point it right. And you can see they're going to connect. And that is what we want. So when we write our answer for our inequality, we either write the word and in there because it connects, and then we circle this and go, oh, that's our answer. Sometimes, though, a lot of times they want us to put the inequality back together. And that's very simple. All you do is you take this one, -3 is less than x. And then instead of writing x again, you just write this inequality is less than or equal to 5. This is also the answer. Okay, hopefully that was a good review. Today, your job is to do the reteaching 3.5 and 3.6. And that should just be a review of the stuff we just talked about. Okay, if you have any questions, make sure you email me. Have a great day.